genetics, understanding heredity and variation. Introduction. Genetic is the study of heredity and variation. It explores how traits are passed down from one generation to next and how genetic information influence the characteristic of living organism. In this report, we will delve into the fundamental concept of genetic under significance. Mendel's laws. Gregor Mendel's law of inheritance lead the foundation for modern genetics. The law includes: number 1, the law of segregation. Each pair of alleles separates during gamete formation. Number 2, the law of independent assortment. Alleles of different genes are sorted independently during gamete formation. Example, a pea plant with purple flower, dominant allele, and white flower, recessive allele, can produce offspring with different flowers colors based on the combination of alleles inherited. Reflection. Mendel's laws demonstrate how genetic traits are inherited in predictable manner, providing insight into the underlying mechanism of heredity. DNA, structure and function. DNA, is the molecule that contains genetic instruction. Its double helix structure consists of nucleotides with sugar, phosphate, and nitrogenous bases. Example, the sequence of nitrogenous bases A, C, G, and T determines the genetic codes which carries information for proteins synthesis and other cellular processes. Reflection. Understanding DNA structure and function is critical for appreciating how genetic information is replicated and expressed. Genetic variation and inheritation. Genetic variation arises from mutation, genetic recombination, and gene flow. This variation can result in different traits and characteristics. Example, sickle cell anemia is a genetic disorder caused by mutation in the HBB gene, leading to abnormal hemoglobin production. Reflection. Genetic variation is essential for evolution and adaptation, but it can also lead to genetic disorder. Understanding the causes and consequences of genetic variation is vital for developing diagnostic and therapeutic strategies. Conclusion. In conclusion, genetics is a fundamental field that explores the intricacies of heredity and variation. By understanding the principle of genetics, we can gain insight into the complex relationship between genes, environment, and traits. This knowledge has far-reaching implications for fields such as medicine, agriculture, and biotechnology. Summary. Genetics is the study of heredity and variation. Mendel's law described the inheritance of traits. DNA, structure, and function are critical for understanding genetic information. Genetic variation arises from mutation, recombination, and gene flow influencing traits and characteristics.
The fundamentals of chemistry. Understanding matter and its interaction. Chemistry is the study of matter and its interactions. It explores the composition, properties, and reactions of substances, from the simplest molecules to complex biological systems. In this report, we will delve into the basic concepts of chemistry and their significance. So let's talk about atomic structure. Atoms are the building blocks of matter consisting of protons, neutrons, and electrons. Understanding atomic structure is crucial for understanding chemical properties and reactions. Now, example. The periodic table organizes elements based on their atomic number or number of protons, and electron configuration helping us predict chemical behavior. Now, in other words, the atomic structure determines the chemical properties of an element, influencing its reactivity and interactions with other elements. Now, let's talk about chemical bonding. Chemical bonds form between atoms, holding them together to create molecules. There are different types of bonds, including covalent, ionic, and metallic bonds. For example, the water, or H2O, is a molecule formed through covalent bonds between oxygen and hydrogen atoms, allowing it to play a vital role in biological systems. Now, in other words, the chemical bonding is essential for understanding the structure and properties of molecules, influencing their activity and interactions. Now, what is chemical reactions? Chemical reactions involve the transformation of substances through the breaking and forming of chemical bonds. These reactions can be classified into different types, such as synthesis, decomposition, and replacement reactions. For example, the combustion reactions, like the burning fuels, release energy and produce carbon dioxide and water. So, in other words, the chemical reactions are fundamental to many natural processes and industrial applications, from metabolism in living organisms to the production of materials and energy. In conclusion, chemistry is a vital field that explores the properties and interactions of matter. By understanding the fundamental concepts of chemistry, we can gain insights into the world around us and develop innovative solutions to real-world problems. Sige, okay na.
Title: The Fundamental of Physics, Understanding Motion and Energy. Introduction. Physics is the study of the natural world around us. It involves the study of matters, energy, and the fundamental laws that govern the behavior of the physical universe. In this report, we will explore some of the key concepts in physics, including motion and energy. In motion is the change in position of an object over time. It can be described in terms of distance, displacement, speed, velocity, and acceleration. Acceleration. Newton's laws of motion provide a framework for understanding how objects move and respond to forces. Example: a car accelerating from 0 to 60 kilometers per hour. The force of the engine propels the car forward, overcoming the force of friction and air resistance. Reflection. Understanding motion is critical in many areas of life, from designing safe routes and vehicles to developing athletic training programs. And energy. Energy is the ability to do work. It comes in various forms, including kinetic energy, the energy of motion, potential energy, stored energy, thermal energy, and more. The laws of conservation of energy state that energy cannot be created of destroyed, only converted from one form to another. Example, a hydroelectric power plant. Water stored behind a dam has potential energy which is converted into kinetic energy as it flows through turbines, generating electricity. In reflection, energy is a vital component of modern life, powering our homes, industry, and transportation system. Understanding energy conversion and conservation is essential for developing sustainable solution to meet our energy needs. Tay, ikaw naman dahil atong uban sa...
So, in conclusion, physics is a fundamental science that underlies many aspects of our lives. By understanding motion and energy, we can better appreciate the world around us and develop innovative solutions to real-world problems. Whether it's designing more efficient vehicles or harnessing renewable energy sources, physics plays a critical role in shaping our future.
That's all, guys.
Thank you.